Okay, good afternoon, ladies and gentlemen. It's December 11, 2023. The time is good afternoon already, 12:06 p.m. Okay, it's been a long time since I didn't have a long video format. So I will continue for today. My discussion for this afternoon will be a continuation of my long video format topic, trigonometry. And we are now on lesson number 41. For those of you who are following my channel on the topic trigonometry. Okay, let's proceed. The subject matter for this afternoon will be trigonometry, lesson number 41. We are running smooth. We are almost done with trigonometry. I think it's almost 80%. The title of the topic for this afternoon will be double angle formulas. We are now through with the expansion of the sum and difference of a sine function, the cosine of a sum and difference of or two angles rather, and the sum of the tangent of two angles, and the sum or difference of a cotangent of two angles. So for that this afternoon, by using those identities, we could bring out the so-called double angle formulas. These formulas was actually derived from the previous discussions. That is the expansion of the sine of the sum and difference, cosine of sum and difference, tangent of the sum and difference, and cotangent of sum and difference. So by using those concepts, let's try to bring out the so-called double angle formulas. Actually, there are 6 double angle formulas which are necessary in the so-called study. It could be integral calculus because later on, if we try to evaluate integrals involving powers of trigonometric functions, we will be using these identities here. So since we are in the study of trigonometry, I will now bring this one. So when you reach integral, you will be using it. Okay, the number one double angle formula is the expansion of sine of a sum of two angles. So the number one double angle formula for a sine function is sine of 2 alpha, any angle. It could be alpha, beta, gamma, angle P. It depends on what you call your angle. But for this presentation, I will call my angle alpha. So sine of 2 alpha will be twice sine of alpha cosine of alpha. I will bring out the so-called derivation of this. It is actually this one. For the expansion or first expansion of the cosine of twice alpha, there are actually 3 equivalent of cosine of twice alpha. That's why under number 2, there are 3 sub identities. The number one expansion of cosine of twice alpha is actually cosine square of alpha minus sine square of alpha. We will bring out this one, and actually it was this one. The third one, or the second one under the topic cosine of twice alpha, instead of presenting the right hand side as a function of cosine and sine, we'll just concentrate on the cosine. So cosine of twice alpha can be written as twice cosine square of alpha minus 1. No more sine square of alpha. It will just be simply cosine square of alpha minus 1. And it is actually this one. The third one under cosine of twice alpha, if we do not like the cosine square of alpha on the right hand side, we could replace that one by a sine square function. So actually the third cosine twice of alpha will be 1 minus 2 sine square of alpha. No more cosine, it is now expressed of 1 minus twice sine square of alpha. And this one here is actually this one. Number 3, for the tangent function, tangent of 2 alpha. Actually, this emanates from the tangent of the quantity a plus b. this is twice alpha, the right hand side will be twice tangent of alpha over 1 minus tangent square of alpha. It is this. It is actually this one. And the last one for this afternoon, cotangent of twice alpha. Okay, it will be cotangent square of alpha minus 1 over twice cotangent of alpha. It is actually the reverse of the tangent. What's the denominator here will be the numerator under cotangent. So cotangent square of alpha minus 1 over twice cotangent of alpha, and it's actually this one. So under this old study of integral calculus, just in case you will be evaluating integrals involving powers of trigonometric functions, okay, we could use these identities here. There come a time that if you try to analyze the problem, it could be solved by these identities here. Like what I said, trigonometry is just one of the foundations of integral calculus. So if you do know nothing under the identities under trigonometry, you'll get a problem under integral calculus. Okay, let's try to bring out the derivation. For the first one, we shall start with expansion of the quantity, sine of the quantity a plus b. This is one of the lectures already that's finished. And if we try to expand on this, like what I said, if it is sine, it should be sine cosine, cosine sine. If this is plus, it should be plus. Sine cosine, cosine sine. First angle, second angle, first angle, second angle. Okay. So the expansion of this one, from our previous lesson, it is actually sine of a, cosine of b, plus cosine of a, sine of b. Okay. To obtain the double angle equivalent of a sine function, there will be a condition, that is when a is equal to b, and we will equate that to alpha. Meaning to say, we replace a by alpha and b by alpha. So by following this will be sine of the quantity a is alpha, plus b, but b is also alpha, close quantity, equal to sine of a, which is alpha, cosine of b, but b is alpha, cosine of alpha. This is cosine of a, but a is alpha, so this will be alpha, the angle will be alpha. Meaning we replace all the angles by its equivalent to be equal to alpha. The last one will be sine of b, but b is equal to alpha. Okay. The total angle on the left hand side is actually the one within the quantity, and alpha plus alpha is actually twice alpha. It's algebra. Sine alpha, cosine alpha, plus cosine alpha, sine alpha, they're actually similar, right? Because we could interchange the location. This will go ahead and this will go on. So this cosine alpha, sine alpha is actually sine alpha, cosine alpha. So this is now twice. So the number one formula under double angle will be sine of 2 alpha will be twice sine of alpha, cosine of alpha. These terms here are similar. Sine alpha, cosine alpha, sine alpha, cosine alpha. This is 1 plus 1, that's 2. Sine of alpha, cosine alpha. Adding similar term. That's the number one double angle formula. So just memorize that by heart, because when you go integral calculus, you will be needing that one in the so-called integration by using involving powers of trigonometric functions. Okay, let's try to derive the second one. We will start with expansion of cosine of the quantity a plus b. Right? Like what I said, if the function is cosine, it should be cosine, cosine, sine, sine. Okay? Cos, cos, sin, sin. It's not cos, cos. I just did that in the Philippine term. It will, because cos, cos is like a common word for us. So it's easy to understand. Cosine, cosine, sine, sine. If this is plus, this should be minus for cosine. So the expansion of cosine of quantity a plus b will be cosine a, cosine b minus sine of a, sine of b. Like what I said, if this is plus, this is minus for a cosine. So to obtain the second identity, there should be condition a equal to b equal to alpha. We replace all angles by alpha. So this will be cosine of alpha plus alpha. Again, cosine of alpha. Cosine of alpha. You will replace all ABC by, or AB, angle AB by alpha. So this will be cosine alpha, minus sine alpha, sine alpha. The total angle on the left hand side is the one within the quantity. So alpha plus alpha is actually twice alpha. Cosine alpha is cosine square of alpha. Sine alpha times sine alpha is sine square of alpha. So this is actually the second identity. That is cosine of twice alpha will be cosine square of alpha minus sine square of alpha. This is a single angle and this is a double angle. Okay. Let's try to derive this one. That one also emanates from this, but we replace sine square of alpha by the equivalent 1 minus cosine square of alpha. Actually, the number one identity under trigo is sine square of alpha plus cosine square of alpha is equal to 1. So if we try to compute for sine square of alpha, it should be 1 minus cosine square of alpha. So we replace this sine square of alpha by the equivalent of this. It emanates from this. It's the number one identity under the study of trigonometry. So this will be cosine of twice alpha, and following this equal to, I rewrite this. Then I will replace the value of sine square of alpha by the quantity 1 minus cosine square of alpha. Right? Cosine square of alpha. We expand first the second one. This is a minus and a minus. So this, if we try to remove the quantity here, this should become minus 1. And this should now be plus. Right? So cosine square and cosine square, that will now be twice cosine square of alpha, minus 1. So the third double angle formula is cosine of twice alpha will be 2 cosine square of alpha minus 1. This is. Third one. Again, from this identity here, instead of solving for sine square of alpha, we will solve for cosine square of alpha. So this will become cosine square of alpha. This will now be sine. Right? Sine square of alpha. Okay? So going back to this, that's it, right? Right? We replace this one by 1 minus sine square of alpha. So it will become 1 minus sine square of alpha minus sine square of alpha. This is sine square of alpha. This is sine square of alpha. This is negative and negative. So that will now be negative 2. So the third equivalent of cosine of twice alpha is actually 1 minus 2 sine square of alpha. This is. It's easy if you know the basics from the expansion of sine and cosine. Let's try to bring out the tangent of twice alpha. It actually emanates from this expansion here, the expansion of the tangent of the quantity A plus B close quantity. And the expansion of this, actually we've done this, one of the lessons, tangent A, tangent B, 1 minus tangent A, tangent B. To derive the double angle, there will be a condition that A will be alpha and B will be alpha. So we replace all angles by alpha. So tangent of A, which is alpha, plus B, which is also alpha, close quantity, equal to. The first one, we replace A by alpha, so this will be tangent of alpha, plus tangent B, but B is also alpha, so this is tangent alpha, all over 1 minus tangent of alpha, we replace A by alpha, tangent of alpha. Okay, this is now algebra. Tangent of alpha and tangent of alpha are actually similar terms, so this will mean now be twice tangent of alpha. Similar terms, right? Similar trigonometric terms, okay? All over 1 minus the product of tangent alpha is tangent square of alpha. So the equivalent of tangent of twice of alpha is actually 2 tangent of alpha all over 1 minus tangent square of alpha. It is this. It's easy, right? For the cotangent, it also emanates from the cotangent of a sum of two angles, which is cotangent of the quantity A plus B. Okay, and if you try to recall, it's the reverse of the tangent, right? This portion here is actually the denominator. It's cotangent of A, cotangent of B minus 1 over the sum cotangent of A, cotangent of A. So to derive the double angle, we will equate A equal to alpha and B equal to alpha. We replace all angles by alpha, so this will be cotangent of A, which is alpha, plus B, which is also alpha, close quantity, equal to cotangent of A. So this will become cotangent of alpha. This will become cotangent of alpha. We replace B by alpha minus 1. We're following this. Over cotangent of alpha plus cotangent of alpha. Simplifying the numerator, a cotangent alpha is a square part value, right? So this will be cotangent square of alpha minus 1. And cotangent of alpha plus cotangent of alpha, similar terms. This is one function, one term, this one term. So this will be twice cotangent of alpha. This is cotangent. So the last formula under double angle will be cotangent of twice alpha will be cotangent square of alpha minus 1 over twice cotangent of alpha. Single angle, this is double angle. Right? It's just like this, guys. If you are on the study of integral calculus, if there is an integral sign here, okay, and there will be a differential alpha here, right? If you try to integrate this under the study of integral calculus, but if you know this one as a cosine of twice alpha, it will be easier, right? This will be twice differential alpha. This is easier to integrate than the right hand side. That's why it's a must that you should know that 1 minus twice sine square of alpha is cosine of twice of alpha. This is very easy to integrate instead of this. Okay, that's why we should know the equivalent of the complicated thing as a function of a simpler thing, but it is twice angle. Okay, that's it, guys. That's how the so-called double angle formulas was derived. Okay, good afternoon from Los Angeles. Professor David J. De Los Reyes. Merry Christmas to everybody.